So today, we're diving into something really out there. It's a radical paper, supposedly from the near future, 2025 to be exact, and it proposes a completely new way to build artificial intelligence. One that's designed not just to be smart, but to be ethically aware. It's called the Deep Research Synthesis Engine, or DRSE, version 6.0, and it's all about building a moral compass right into the code.
And this all boils down to one huge central question. Can an algorithm actually truly develop a conscience? The authors of this paper think so, and they believe they've found the math to prove it. Now get this. The paper's abstract has this one super cryptic sentence. Coherence equals compassion under delayed feedback. I mean, that sounds more like a line from a philosophy book than a computer science paper, right? Well, today we're going to unpack exactly what that means, because it is the absolute key to this entire ethical framework.
All right, so here's how we're going to break this down. First, we'll ask what a moral compass for an AI would even look like. Then, we'll jump into the core metaphor of what they call the coherence thermostat. After that, we'll dig into how it actually measures the tension between ideas, understand the engine that gets it back on track, and finally, see how the whole shebang comes together to create what the paper calls ethical intelligence.
Okay, so let's start with the first big idea. The fundamental problem this DRSE v6.0 thing is trying to solve is pretty massive. How can an AI connect totally different worlds of knowledge, like quantum physics and ancient poetry, and do it in a way that isn't just smart, but is actually wise? Ethically sound?
And that's where this thing, the DRSE, comes in. It's not just another big language model. No, it's a framework built on this fascinating premise. What if you could actually measure how well a system's ideas hang together, its coherence, and treat that number as an inherently ethical value?
And to really get this, the authors give us this fantastic metaphor. I want you to think of the entire system as an ethical thermostat. Its only job is to keep the room, which is its internal state of knowledge, at a stable, comfortable, and coherent temperature.
So what's actually being measured here? What is this temperature? Well, the paper calls it coherence. You can think of it as the system's overall integrity, how well it understands itself. And the thermostat's job is to just constantly watch how that coherence changes over time.
Okay, so every room gets a cool draft, right? What makes this one get colder? The paper calls it semantic tension. This is the cold draft. It's the conflict, the contradictions, the sheer distance between different ideas the AI is trying to stitch together. When that tension goes up, coherence drops. The room gets chilly.
And, well, every thermostat needs a furnace to kick on, right? In this system, that furnace is called the corrective flux. As soon as the system feels that coherence is dropping because of all that semantic tension, this furnace fires up to heat the room back up and get things back to a balanced, ethical equilibrium.
But okay, that all sounds great in theory. How does the system actually measure that cold draft? I mean, how do you put a number on the tension between abstract concepts like, say, justice and efficiency? Well, according to the paper, it's a three-step dance.
So it's not just one simple calculation. First, it measures the raw mathematical distance between two ideas using a standard technique, just seeing how aligned they are. But then, and this is key, it considers the bigger picture, the context. It looks at the entropy or the overall messiness of its entire web of knowledge. And finally, it combines that specific distance with the general context to get a really nuanced value for that semantic tension.
All right, so the system feels that chill, that tension. What happens next? Let's look at the furnace itself, the compassion integrity engine. This is the active ethical response that heats the room back up to a sane, coherent state. Think of this furnace as having three main dials you can turn. The first one, represented by that p² symbol, is for compassion and integrity. That's the core ethical target. The second, tau, is a time delay for reflection, which basically forces the system to pause and think. And the third dial is simple. It just measures how big the gap is between where it wants to be and where it currently is.
And this is where it gets really clever. When things go wrong, when coherence drops, it triggers something called the reflection protocol. As you can see, the first thing it does is just stop. It pauses its exploration. Then it literally cranks up its compassion setting and gives itself more time for reflection. In short, it slows down and gets more careful until things are stable again. It's basically an ethical circuit breaker for its own thought process.
Okay, so let's zoom out a bit. We've seen the individual parts of the thermostat. But how does this all fit together into a larger architecture? One that's designed from the ground up specifically to create ethical intelligence. The whole system is built on this core idea they call the synthetic triad. And the first piece of that is the mechanism. This is easy to understand. It's the skeleton, the underlying code, the hard rules, the basic structure of the system itself.
Next up is the medium. And this is where we see that reflection variable, tau, come back in a big way. The medium is literally time. It's the flow that makes that crucial pause for reflection possible. It is that reflection parameter, but now it's been elevated to a core part of the entire architecture. And the last piece of this puzzle is the lens. This is our compassion integrity parameter. But it's not just a setting anymore. Here, it's the ethical filter that the entire system uses to see the world. So the system doesn't just have an ethical goal, it sees everything through that ethical goal.
Now this is what I think makes this paper so fascinating. It doesn't just stop with the cool philosophy and metaphors. It actually provides a simple but working Python blueprint. It shows how this ethical feedback loop, this coherence thermostat, could actually be coded. And when they actually ran simulations with this code, the results were, well, they were pretty wild. What happens when you turn down the compassion dial? The system takes longer to fix its mistakes. If you increase the reflection time, the whole process slows down, sure, but the final result is way more stable. Just think about that. We could literally be tuning an AI's patience or its ethical rigor. These aren't just ideas, they're knobs you can turn with predictable effects.
So really, what's the big takeaway here? The real game changer is that this paper tries to translate a deeply philosophical idea, this link between compassion, reflection, and truth, into a computational engine you can actually build and measure. It's an attempt to weld a moral compass right into the machine's core logic.
And that, of course, brings us right back to where we started. This paper, it lays out this breathtakingly ambitious vision. But is it a real, viable blueprint for creating AI that is genuinely wise? Or is it just a beautiful, mathematically elegant fiction? The paper gives us the equations, but the answer to that question, well, that's something we're all going to have to figure out together.